Okay, so answers to exam 3 in Chem 230, spring 2020. Questions 7 and 8 I should be able to knock out pretty quickly. S1 chloroethanol. We wanted a Fisher projection for that. Now if you just draw the Lewis dot structure, you'll be able to see clearly what things are connected to the chiral carbon. So here we have our chiral carbon that has an OH, this is carbon number 1. The ethanol is ethyl alcohol, so eth means 2 carbons, alcohol is the OH group. So on carbon number 1 we have the OH, then carbon number 1 also has a chlorine, carbon number 2 is a methyl, and carbon number 1 also has a hydrogen. So now if we want to get the S isomer intelligently, we recognize the atomic number of chlorine is 17. That makes it the top priority group. The atomic number of oxygen is 8. So that makes OH the second group. Atomic number of carbon is 6. That makes the methyl the third group. And so the way I've got it drawn here, if this was a Fisher projection, it would be going clockwise, 1, 2, 3 with the hydrogen in back. If we want proper perspective, put the hydrogen in back. And now we want to make sure our number 1 group, the chlorine, is in our sort of starting position. But now if we want it to go counterclockwise to give us S, we now have to put the second priority group on the left, and then the third priority group on the bottom. So we go 1, 2, 3 counterclockwise for S1 chloroethanol. And then the next question, and apologize, I don't have the questions in front of me. I'm trying to remember. It was a C5 H10, and we wanted geometric isomers that have a double bond. And the thing is, with the geometric isomers, whenever I hear geometric isomers, I'm going to immediately think cis and trans. And if we had a ring, we're talking about the top of the ring and the bottom of the ring as being our orientation points. And cis would mean both same side of the ring, trans would be opposite sides of the ring. With double bonded things, you have the line of the double bond, the axis of the double bond as your reference point, and so if you have a double bond, now you would want the hydrogens that are on the double bond to either be next to each other or across from each other. If you have trans to pentene, that would be an example where the two hydrogens are across from each other, opposite sides of the double bond. And then if you put the hydrogens next to each other, then the other substituents, 1, 2, 3, 4, 5, there's cis to pentene, where pent means 5 carbons, ene means you've got your double bond, 2 means the double bond starts on carbon number 2, 1, 2, 3, 4, 5, and then cis means the two hydrogens are next to each other or on the same side of the double bond, using the axis of the double bond as your frame of reference. So nice, simple. If you understand there's 1 degree of unsaturation here, it's going to be a double bond, and then how your geometric isomers are cis or trans versions of the same constitutional isomer. So if you put 1 pentene and 2 pentene, those are different constitutional isomers. You don't want to go down that road. So there it is, video answer key supplement. Hopefully this helps as you get ready for the final.